I'm stuck in my place. Okay. Introduction into similar polygons. We've already dealt with congruent triangles, and we've talked about congruent polygons. And what was true about that?
They're congruent.
What does that mean, though?
They have equal angles and equal sides.
That every corresponding part is congruent to the other corresponding parts, right? So if you laid one on top of the other, then you really couldn't see the other one anymore because they're exactly the same. Similar polygons are sort of the same thing, except they're proportional to each other. They have a ratio of their sizes. So I might show you a stop sign looking octagon, and then show you another one, but it's just maybe half the size, okay? So those two things would be similar if all the corresponding parts are exactly half the size of each other. Now, but to be able to work with all that information, we need to be able to use ratios very easily. So, ratio number one, what is a ratio? It is a comparison of two things expressed in simplest forms, or simplest terms, shall I say. Now, when you're comparing ratios, you have to be comparing apples to apples.
I love that game.
It has to be two things that make sense. All right? You can't compare the size of a school bus to the number of days a student is absent. You could compare the size of a school bus to the size of a mouse because you're comparing size with size. You could compare the number of days a student is absent with the number of days a teacher is absent because you're comparing the same thing, okay? All right? If I was to write a ratio of boys to girls in this class right now, we have 3 boys and 8 girls. The first expression is a ratio, the number with the colon and then the number that follows. It must be expressed in lowest terms. So you need to make sure that 3 and 8 can't be reduced by something, which in this case it can't. So what does that ratio mean exactly?
For every 3 boys, there's 8 girls.
For every 3 boys, there are 8 girls. All right? Now suppose this was an auditorium filled with students and the ratio of boys to girls was 3 to 5. Excuse me, 3 to 8. Suppose I said that there were 24 girls. How many boys would there be?
9.
How'd you figure out 9, Elise?
Because 8 times 3 equals 24, and then you have to multiply 3 by 7.
Because I took this ratio of 3 to 8, and I turned girls into 24, which means I multiplied it by 3. I made 3 times more girls. Well, in order for the ratio to still be the same, I have to have 3 times more boys as well, okay?
So would it be like 9 to 24?
No, we would simply say there are 9 boys and 24 girls. We don't express that as a ratio because it's not in simplest terms. Now, a ratio can also be written as a fraction. All right, if I said the ratio of boys to girls, I could also put it as 8 over 3. Oh, excuse me. Is that correct, boys over girls? That worked out good. Why not? Because I'm supposed to be identifying the number of boys in the numerator, and I've just reversed it, making it look like there are more boys than girls, when in actuality, there are less boys than girls. So does it matter the order that you write the numbers?
Yes.
Absolutely, positively. Okay? All right. Here's a picture of a what? Okay, let's do a little review real quick, and this will be like a little lesson for those of you who weren't here. Let's talk about a trapezoid. How many sides does a trapezoid have?
4.
So that means it's called a
Quadrilateral.
quadrilateral. How many pairs of parallel sides does a trapezoid have?
1.
Only one. What are those parallel sides called?
Base.
The bases. The non-parallel sides are called.
Legs.
What is it called if the legs equal each other?
Isosceles.
An isosceles trapezoid. What do we know about the base angles of isosceles trapezoids? They are congruent to each other. So in other words, angle D and angle I would be congruent to each other if this was an isosceles trapezoid. So is this an isosceles trapezoid?
No.
No, it is not. Because the base angles are not congruent. Now, because ZO is parallel to DI, what do we know about angles Z and D? Always. They are going to be supplements because they are
Same side.
Interior angle.
same side interior angles formed by parallel lines cut by a transversal. In the same sense, angle O and angle I are going to always be supplements, whether it's an isosceles trapezoid or not. That will always be true. All right. Now, using the measurements and the information we have there, we're going to look at different ratios and state them in lowest terms. If I asked you to find the ratio of angle Z to angle D, first thing you must do is identify the measure of angle Z and angle D, and then do what?
Simplify.
Reduce them by whatever they can be reduced by. Well, angle Z has a measure of 120, and angle D has a measure of 60.
They can both be reduced by 60.
So the ratio is
2 to 1.
2 to 1. Why 2 to 1 and not 1 to 2? Because Z is bigger, and Z is named first. So the ratio of angle Z to angle D is 2 to 1. Suppose I asked you to find the ratio of angle O to angle Z. Well, angle O has a measure of 110. Angle Z has a measure of 120. What can you reduce those two numbers by? 10. You have to be able to reduce them by the same number. They both can be divided by 10, which would give you 11 to 12. 11 and 12 cannot be reduced by the same number. So that is lowest terms.
111 is fine.
Yes. Did you say 111?
I said 11 is
Oh.
fine.
Got you. All right, now find the ratio of ZD to OI. And I apologize, I shouldn't have a brace over that. I mean a line over that. What's the measure of ZD?
Wait,
ZD is the
6.
length of a line segment.
Is 6
It's 6B. ZD is the measure of a line segment joining point Z and point D, and it's got 6B. What's the measure of OI?
14.
What is this reduced to lowest terms?
3.
3B
7.
to 7.
Oh, I was gonna so complicated thing. I was like trying to divide and stuff because you could do it.
You can't figure out B because you don't have an equation here. You simply have a comparison going on. All right? You can reduce 6 and 14 by 2, but the B is still there. All right, so taking numbers and reducing them. Okay? Now suppose I told you that here is the dimensions of a poster or something.